Hello, today we will recap a few divisibility rules and solve a few questions on them. This is not a comprehensive coverage of divisibility rules. The details of it, what are the rules, why do they work, insights into them, solved examples, all of that is covered in the course. Here this is just a promotional video, just giving you some tidbits of it. Divisibility rules can not only check whether a number is divisible or not, but can also be used to find the remainder. So we will find the remainder, and if the remainder turns out to be 0, it is divisible, and if it's not, we have the remainder with us then. So checking remainders or divisibility rule by any power of 2. So it's not just 2, 4, but it is any power 2, 4, 8, 16, 32, and you can extend the rule indefinitely. So let's say you are checking it by 2. So the remainder when a number is divided by 2 is same as when the last digit of the number is divided by 2. The remainder when a number is divided by 4 is same as the last 2 digits divided by 4. So if the number is a long 7, 8 digit numbers, you don't need to deal with the entire number. Just take the last 2 digits divided by 4. Whatever is the remainder will be same as the remainder when the entire 7, 8 digit number is divided by 4. So you got the idea. You can keep extending it. So you want to check the remainder when you divide by 8. Just divide the last 3 digits by 8. You want to check the remainder when divided by 16. Ignore the big number. Focus only on the last 4 digits. And divide that by 16. Whatever is the remainder is going to be same as the remainder when the entire number was divided by 16. And if those remainders are 0, if the last digit is divisible, then the number is divisible by 2. Last 2 digits is divisible by 4. The number is divisible by 4. Last 3 digits is divisible by 8. The number is also divisible, and extend it further also. Like for 16, I had a student ask a question, how are you using divisibility rule of 6? 16 is the same. 16 is 2 raised to 4. So check the last 4 digits. We have a question today, so we'll have a look at it at that time. Yeah, so check the last 4 digits. If it is divisible by 16, the number is divisible by 16. And the funny thing is the exact same rule works also for 5 raised to n. And why does it work for 2 raised to n and 5 raised to n and not for other numbers? That's also very interesting to think. We use the decimal base system, that is 10, and 10 is 2 into 5. That's a hint to it. So the idea is the same. So let's say we have a number, you want to check when it is divided by 5. Just take the last digit, divide by 5. Whatever remainder you get is same as the remainder when the entire number is divided by 5. If you were checking divided by 25, 5 square, all you need to do is take the last 2 digits and check divisibility by 25. If it's divisible, the number is divisible. The last 2 digits are 0, 25, 50, 75. Then the number is divisible by 25. Or else whatever is the remainder that you get is the remainder when the number is divided by 25, the entire number. So for 125, take the last 3 digits and so on. You can even extend this rule, right? And the next rules are for divisibility rules for 3 and 9. Now, if you are checking divisibility by 3, the remainder will be same as the remainder when the sum of digits is divided by 3. So now you have a number, whatever large number it is, you need to add the digits, sum of digits. So that is new now, the sum of digits, and whatever is the sum of digits that you get, let's say the sum of digits is 20. So 20 divided by 3 leaves a remainder 2. When the big number is divided by 3, the remainder will also be 2. Okay, and if it is divisible by 3, then the number is also completely divisible by 3. It directly follows. Once you know the remainder, if the remainder is 0, it is divisible. The same logic works for 9. Here also you take the sum of digits, but this time you divide it by 9 and not 3. Right? So for 3 and 9, it's sum of digits divided by 3 divided by 9. And this rule cannot be extended. Just because 3 and 9 follow that same powers of 2, powers of 5. So one might get a wrong idea, 3 to the power 1, 3 square, 3 cube, 27. No, this rule cannot be extended. And why these are insights, students? Why these rules work? You'll have to watch the videos in the course for that. Okay. So another rule that we use is divisibility by 11. So there are questions on divisibility by 11 also. We'll quickly move to the questions. Let's wind this. So what we do over here is, if we have a number, so let's say the number is A, B, C, D, E, F, and it could be anything. Start with the unit digit and add alternate digits. So this sum that we start with the unit digit, okay, this sum of all alternate digits, we call it U. And then the other alternate digits. So do I have this? Yes. So now start with 10, the other set of alternate digits. And it doesn't matter how many are there. Okay, add the other set of the sum of the other alternate digits. Let's call it T because we are starting from the tens place. Right? So we get U and T. Now, when the number is divided by 11, the remainder will be U minus T. And the order is important. It has to be U minus T. And the remainder we know has to be a value between 0 to 10. When divisor is 11, the remainder is leftovers. You cannot further divide. You cannot make another group of 11. So what will be left over will be 0 to 10 only. But if this number turns out to be greater than 10, and it could be, then what you just do is you subtract 11. And sometimes just subtracting 11 won't work. So you subtract 11s, as many 11s as you want. So for example, if U minus T is 30, now 30 is a very large number. It can't be the remainder. So 30 minus 11, 19. 19 is still larger. 19 minus 11, 8. That will be the answer. So you subtract 11s. Keep subtracting as many. Similarly, if this number turns out to be less than 0, negative, this might turn negative. You can't change the order just because it's negative. What you do is you just add 11s this time. Right? So more details in the course, students. Right? This is just a gist of it. And to end this rule, this is when you're finding the remainder and the number is divisible by 11 when obviously the U minus T, it could be 0. So most people just think of this one value 0. If U minus T is 0, the remainder is 0. If the remainder is 0, it is divisible, right? But it need not just be 0. It could also be 11. It could also be 22. It could also be 33 and so on, students. And if these are the values, it could also be minus 11. It could also be minus 22. It could be minus 33 also. So there can be many series of 11, any multiple of 11, positive or negative. then the number is divisible by 11. Okay, so straightforward questions come in, but we are going to see some interesting one. And before we reach that, we found rules for most prime numbers. Let's check for a few composite numbers. So for example, if you want to check divisibility by 24, you split 24, but you don't split it into, there is a common factor. You should not try to keep a common factor. So if you split as 2 and 12, there's a common factor. Now this common factor is going to make things bad. Okay, you split it as two numbers which do not have a common factor and for which the rules you know already. Okay, you can even split a large number into three numbers, but then there should be no common factor between the three numbers. Okay, and then check the divisibility by each of them. Okay, so last, let's wind it up now. There is this number 1001 which keeps getting repeated quite often. And this 1001, when you factorize it, you find it's a multiple of 7, 11 and 13. It's an important number to keep in mind. Okay, so there are some, as you solve more difficult questions, now you might find remainders linked with 1001 and so on, right? So this is a little tougher part. So what the link over here is just that if we have any single digit a written 6 times, like this number a. Now this number can be written as, it's given how, you can read this up yourself, can be written as the number a multiplied with 1001. And 1001 we know is a multiple of 7, 11 and 13. Hence this number, a digit repeated 6 times, becomes a multiple of, it's a multiple of 1001. That means it's a multiple of 7, it's a multiple of 11, it's a multiple of 13. So a number written 6 times is a multiple of 7, gets used in quite a few of tough questions. Okay, that's the only takeaway here. We have one question on that as well. So let's move to the questions and let's have a look at the questions. So let me just increase or make it a full screen and then we'll be able to solve it. Okay, so let's see. This is question number 10. So let me start with question number 1. Okay, question number 1. If this number is divisible by 6, now 6 in your mind should first be broken as 2 into 3. Both are co-prime. There are no common factors and we know the rules for both 2 and 3. So for this number to be divisible, it should be divisible by 2 as well as 3. It's useful to start with larger rules. So let me start with 3, the sum of digits. So I'm going to add up all the digits. So if I add up all the digits, 4 and 8, 12, 12 and 2, 14, 14 and 5 is 19 plus 2x. So this number is divisible by 3. So it's a multiple of 3, but it is more than 19. So let's see 19, what's a multiple of 3 more than 19? X could be 21 is a multiple. So this is 19, so this could be 2. So that is x could be 1. 24. So if this is 24, this has to be a 5. This can't be a 5. Okay. 27. If this is a 27, this number needs to be a 8. Right? It could be 2, 5, 8, increments of 3. So if this number is 8, x could be 4. And such, if you see, it's an increment of 3, 3. So x could also be 7. 7 2s are 14, 14 and 29. is 33. 33 is divisible, and more 3 would make it a double digit, but x is a digit. By a digit we mean a single digit, so it can only be 1, 3, 1, 4 or 7. But this is for divisibility by 3. And for divisibility for the number is divisible by 2. For 2, x has to be even. The last digit has to be divisible by 2. So the only even number that we find if I want both the things is x is equal to 4. So pretty easy one to begin with. There's no difficulty here. Okay. So you have the whole different types of questions. So let's erase this, go to the next question. Okay, we haven't reached the next question, is it? Okay. So what is the remainder when this number is divided by 11? Good. So question of remainders divided by 11. So by 11 what do? We take alternate digits. So start with 8. Leave the a, 8 and 6, 14, do it in your mind, 14 and 3, 17, 17 and an 8, 25, and there's an a. So u is 25 plus a. And the other set of numbers starting with tens digit, 9 and 5, 14, 14 and an a, 14 and a 6, 20, 20 and this 22. So 22 plus a. The remainder is u minus t, and if I do u minus 2 I get a 3. Thankfully this is this in the range 0 to 10? Yes. So this is my answer, or else we would need to those add 11s or subtract 11s. Here we don't need to do anything. This is my answer. It doesn't depend on a. A could be any number, it doesn't really depend. Any digit it could be. So again, not a very difficult one. So third question. If a number is divisible by each of. Now this is a little unusual question. It's not checking a divisibility rule, but then in GMAT there are many such questions and they can be a little tricky. Is divisible by each of these numbers, and which of the following is not necessarily true? Yeah, is not in the negative sense, not necessarily true. So the best way is, in this you have to take each number and break it into, powers of prime. So 2, this is divisible by 2, 4, 8, 16 into 5. So it is divisible by 2 raised to 4 and 5 raised to 1. Try to split it such that there's no common between them. Similarly, 90 has 9, that's a power of 3, 3 square, and 10 is 2 into 5. So 90 I would break it as 2, 3 square and a 5. And 100 is nothing but 4 into 25, 2 square into 5 square. So if it is divisible by all of it, what I'm certain is it is definitely divisible by 2 raised to 4. It is definitely divisible by 3 square. The highest power of 3, 3s are not present there here, but it's present here. And the highest power of 5 is 5 square. So it is divisible by this number. Okay, rest I'll have to use the option. So let's see, the number is divisible by 36. Do I have a 36 here? 9 into 4, 36. Yes, this is necessarily true. We want which is not necessarily true. The number is divisible by 180. Now break 180 again. Here also you should have seen this is 4 into 9. So 2 square into 3 square. Similarly, if I write this is 36 into 5. 36 into 5. 36 you already have. 2 square into 3 square into 5. So do I have all those powers? Yes. So this is also necessarily true. The number is divisible by 400. 400 is 4 into 100. 100 we already have, so this into 4, which is as good as 2 raised to 4 into 5 square. Is the number divisible by 2 raised to 4? Yes. Is it divisible by 5 square? There's no common factor, it will be divisible by the product also. So this sentence is also necessarily true. So this has to be my answer. And this 5 into 100, 100 is this into 5, so this is 2 square into 5 cube. Now the number need not be divisible by 5 cube. The number is divisible by 5 square. It need not, it may be. Yeah, if it is, it's a multiple of this. If there's another 5, a fifth multiple, it will become divisible, but it need not always be. So need is not necessarily true. So this is my answer. Again, not a very tough one. So good, 3 questions, that's good speed. Let's go to 4th, one more question. Let's see how tough, easy this is. If the number, and now I don't have an x, I don't have a y, is divisible by 88, what value can x assume? X and y are two distinct, don't forget this word. Yeah, such words make things quite, sometimes one misses out these words. Such errors one can't afford in CAT. Single digit whole numbers, a 0 is allowed, so x and y. So this is divisible by 88. So 88 is broken as 8 and 11. Both are co-prime. So you need to use divisibility rule of 8 and that of 11. Now when you use 11, the entire number will be used. So both x and y will come. But when you use divisibility rule of 8, when you use divisibility rule of 8, you are only focusing on the last 6, 8, y is divisible. So by 8. So 8, 8 is a 64, 40, y, 4y. And that is divisible by 8. So in 40s, what is a number divisible by 8? So y could be 0 itself. 40 is divisible. Y could be 0 or y could be also 8. 48 is also divisible. After 40 you have 48. So y could be both of it. Remember, now do you see this role of 0 also possible? The y could be a 0 here. Okay, but the question is asking us x. So now I have to move to 11. So take this case now. So if I take this case, y is 0. And now I have to use rule of 11. So let's do that alternate. Remember, y is 0. So 0 plus 6, 6. 6 and 9, 15. 15 and an x and a 1. So u is 16 plus x. And t, so the alternate ones 8, 8 and 2, 10. 17, 17 and a 4. 17 and a 4 is 21. So when you do u minus t, what we get is x minus 21 or minus 5. Now, so this number should be 0 or a multiple of 11. Now, so what value will make this 0? So this value that you get 0 is x is equal to 5. So if x is 5, this would become 0. Yeah, this would be 11 when x is 16, but x is a single digit whole number, no? So x can't be 16 and so on. So x is equal to 5. The question is asking what value can x assume? I see a 5, but I also see a 5 or an 8. So you'll have to take the second case also. So if I take the second case where y is 8, so the u this time, only thing that changes is instead of 0 it becomes an 8. Okay, so an 8 gets incremented over here, so you would be getting the sum will be 24 plus x. You could put that 8 and try it. 8 and 6, 14, and 9, 23, 23nx, 24nx, 24nx. And the tens digit doesn't end up any different. So u minus t in this case is u minus t is 3 plus x. Now if 3 plus x, yeah, pay attention to this, 3 plus x. So now this 3 plus x, if you want it to be 0, this gives me x is equal to minus 3. But since it's a digit, you can't have a minus 3. But remember, this could even be 11. This could even be 11. And if this is 11, okay, 8 plus 3x could be 8 also. So you put x is equal to 8. This 8 that you have here, this 8. Yeah, you put x is equal to 8, put y is equal to 8, and you will find that this number is divisible by 88. So what is the problem? The problem is this word here. If x is equal to 8 and this case is y is equal to 8, they are no longer distinct. So the only acceptable value here is x is equal to 5. That was a little nasty, point over there. But then yes, you need to be alert to all such points. Moving ahead. So questions are slowly getting a little more trickier. So fourth done, 6 more to go. Fifth question. So how many values, so how many, yeah, it's not a what value, it's how many can x assume if this number is divisible by 24. We have checked earlier also, for 24 you divide it as 3 into 8. So this number is divisible by 3 as well as 8. X is a single digit, it's a digit, okay, whole number, 0 is allowed. So now you check by 3 and by 8. So for divisibility by 3, you check the sum of digits. So I'm just going to add the digits, 9, 9. And you know what? You can drop multiples of 3. So if the sum becomes 9, you can just drop it off. Yeah, you can ignore that. It's just to keep values short and so on. 8 and 2, 10. 10 again, I'll drop a 9, I'll just count it as 1. Now these are not things which are very important. If this unsettles you, and they do unsettle a lot of students, then just add the digits in your own way. You don't need to follow everything exactly like I do or so on, right? So that's a 1 and a 5, 6. 6 is also multiple of 3, drops 9. 6 is a multiple, 9 is a multiple. So basically when I take all these digits, I get a multiple of 3. Plus x. So what can x be? X can be any multiple of 3. So it could be 0 or 3 or 6 or 9. It could be any of these. Okay, but I also want to check divisibility by 8. And for 8, I just need x, 9, 6. That's it, last 3 digits. That's the divisibility rule of 8. So these 3 digits as a digit should be divisible by 8. Now the unknown is in the hundreds place. If the unknown is in the hundreds place and it's divisible by 8, so now there are two things that I'm talking about. It's in the hundreds place and it's divisible by 8, tells me that x could either be along the set 0, 2, 4, 6 or 8, or could be the other set 1, 3, 5, 7, 9. How do these things come about for? It will get too lengthy if I explain all these things here. So you just check any one number. So if I put a 0, is 96 0 96, which is 96. Is it divisible by 8? Yes, 8 12s are 96. So if a 0 is allowed, all these will be allowed. And then this set won't be allowed. You can put a 296 and check divisibility by 8. It will be divisible. Put a 4, it will be. So x could be anything out of 2, 4, 6, 8. So if I club these two, then for both, satisfying both the conditions, x could be 0 or it can't be 3 is not present here or so on. So 6, 0 or 6. These are the only two values that X can assume. This is also a very nice theory. The idea, the hint I am trying to tell you is, if you increment this by 1, the number gets incremented by 100. But 100 is not divisible by 8. 8 12s are 96, 8 13s are 104. But if you increase this number by 2, the number gets incremented by 200, and 200 is divisible by 8. 25 into 8 is 200. So when you increase it by 2, the number will remain divisible by 8 if it was originally divisible. So that kind of a logic it is, but maybe for some other point, right? So good question. Yeah, two values, and let's continue. What next do we have? I have to go to the next question. Have we reached? Not really. Okay, so is divisible by 99. If this number is divisible by 99, 99 is 9 into 11. Find the value of X into Y. Now this is a nice tough question. This is one of our tougher questions. But it's a pretty standard question. If you have practiced a standard set of material, while this question may be a little lengthy, but if the method is known to you, you can do it in exam situation. So 9 means you need to use both of them. So all of them. So again I'm adding them up, and when I'm adding I'm dropping the 9s. 4 and 5 is a 9, I'll just drop it. 8 and 1 is a 9, I'll drop. 7 and 2 is a 9, I'll drop it. So what I just left is 6 plus X plus Y. So for divisibility by 9, the X plus Y, it's 6 plus X plus Y should be divisible by 9. It will be more than 6. So what's the multiple of 9 more than 6? 9 itself. So this could be 3. Or it could also be add 9 more to it. It could also be 12. You could even continue, but then 12 and 9 would make it 21. But single digit numbers cannot add up to more than 18. Okay, they are X and Y. 9, 9, 18. It can't cross 18. So you get two values. This is what I meant by, if you have practiced this, you would know that you are going to get two values here. Okay, now coming back to the number, now I have to use divisibility rule of 11. So pay attention, a little tricky this is. For 11. For 11, what I do is units, 6 and an X, 6 and a 7, 13 and a 1, 14. U is 14 plus X. T, 5 and a Y, 8 and 5, 13, 13 and 6, 19. 19 plus Y. I'll do U minus T. So when I do U minus T, this minus this, we get an X minus a Y, and we also get a minus 5. So now this number could be minus 22. It could also be minus 33. Somewhere I have to start. So I'm starting with a minus 22, minus 11, 0, 11, 22 and so on. Take the 5 to this side. You will be getting the value of X minus Y. And remember, X minus Y, X and Y are again digits. So now the difference can only be from minus 9 to plus 9. If this is 0 and this is 9, the difference is minus 9. If this is 9 and this is 0, the difference is 9. And these are the extreme cases. Check any other value, it will be between them. So if you add a 5 to this becomes 17. It can't be. Minus 17, it can't be. This value has to be between minus 9 to plus 9. It can't be anything else. Add a 5 to this, you get a minus 6. So yes, it could be a minus 6. Add a 5 here, it could be a 5. Add a 5 here, this could become a 16. The difference can't be 16. So again you get two values. Now if you know the sum and the difference, you should be able to find your x and y very fast. Add them, divide by 2. So when I add them, I get -3. So x can't be negative, ignore. If you add these, 3 plus 5, 8. 8 by 2, 4 is a possibility. But then if x is 4, y is -1. This can't be possible. Let's add these two. 12 and a -6 gives me a 6. By 2, 3. And if x is 3, y could be 9. Automatic. So this set of values look perfect. If you add these two, 12 and 5, 17. 17 by 2 is a decimal value. So this is the only possibility. 3 and 9. So x, we want the value of x into y. 9 3s are 27 should be our answer here. So again, this is, if you're struggling over here, what is happening? I'm again telling, I can't really make this into a, a course kind of a lesson or so on. Yeah, we are just trying to tell you that these are very standard things. If you have done this chapter from any good course material, these should be known to you. Okay. If this is the first time you're doing, acceptable that you might not know. But whatever we did here, as in how to find x and y over here, these two, these two, these two, these two. These all things are very commonplace working, students. Okay. So, okay, moving ahead. So, next question, 7th question. Questions will keep getting trickier and trickier. A number is made up of only the digit 9. Example 9, 99, 999 or so on. So this should remind you of that number A. Right? 6 times when you write any digit 6 times. Remember, then such a digit is divisible by each of 7, 11 as well as 13. So let's see, find the sum of the digits of the smallest such number divisible by 7. So one thought is you could have even just checked each. Is this divisible by 7? No. Is this divisible by 7? No. And how do you check? You just divide by 7. 7 ones are 7, 29. 7 4s are 28, 19. 19 is not divisible. But anyways, if you know this, you could have directly found the value that when you write it 6 times, this is divisible by 7. And the question is asking us sum of digits. So 9 6 are 54. If you knew it, this becomes an easy question. If you did not knew it, you would need to do this work. But any decently well prepared students would know that, students. Okay. Oops, we went back. So where are we? Next question, 8th question. Interesting, I think so. It's good, getting a little lengthy. Should we do? Okay, let's do it. X and Y in the numbers below refer to single digit whole numbers. So digit, they could be 0 also. Which of the numbers can never be divisible by 11? So again, a simple question on rule of 11. Good, we can practice a rule of 11. Rule of 11 does trouble. So let's start. 6 and an X and a 3, 9, 9 and a 2. 11 plus X is a U minus T. 2 and an 8, 10, 10, 17, 17 and a 9, 26. So U minus T. So U minus T simply becomes X minus, what is that? 11 minus 26. So that's what? Minus 15, is it? Yes. So X minus 15. Now, this X minus 15, mind you, could be 0, but it could also be minus, and I like to take it from a length. Yeah, you could even take it from minus 11, but just, you know, again, to be very err on the extreme side, I'll take it this way. So this will give me x is equal to, add a 15. So when you add a 15 to this, I get a minus 7. X can't be negative. When you add a 15 to this, you get a 4. X could be a 4. When you add 15 to this, so no further values, but x can definitely be 4. So which of the numbers will never be divisible? This number will be divisible for x is equal to 4. Okay, and I'll leave the work for you to do it here and check. The answer is almost visible here. So, okay, let me first go to this and check it up. 1 is divisible for a value, but it is not divisible for any value of y. That, it seems, is the answer. So you need to check why does it not work in the second case. Chalo, let's do it. The video gets a little lengthy, but no problem. So let me just do it. So in the case of the second number, this is what, 8th question. 6 plus 3, 9, 9 and 6, 15, 15 and an 8, 23. 0 plus a y plus a 9 and a 13. So that's a 13 plus y. So u minus t, okay, which is a 10 minus y. This could be amongst many things. It could be minus 22, it could be minus 11, it could be 0, it could be 11, it could be 22, or so on. Okay, so you could even interchange this, the negatives will change, or just find the value of y. Do it on your own method, students, whatever we have. So I'm just writing the value of y directly. If I want this number to be minus 22, y will be minus 12. Is it? No. Y will be minus 32. Oh, you can't have such an, just as this incremented by 11, keep increasing this by 11 also. That's it. So if you add 11 to it, you get 23. Check 10 minus 20. Okay, 11, when I add this, I'm making a mistake. Add 11 to this, minus 22, minus 21, is it? Okay, so let me check. You just plug this in over there. Oops, I think so I've done all of this wrong. So let me restart. If I want 10 minus y to be a minus 22, y could be a 32. 10 minus 32, not a minus 32, but a 32. Again, you don't need to follow exactly what I am saying. You could rearrange it. Y minus 10, reverse all this, then take 10 to this side. Do your own pencil work, calculation work. Follow your own, students. Don't you know, force yourself to think the way someone else thinks, or so on. So, and find your own ways. Like, I know that this difference has to be 11, 11, 11, 11. Okay, so if I want this to be a minus 11, the 22, 21, 21. And obviously y can't be these values. It's a single digit value, right? So subtract 11, 10. Okay. And subtract 11 minus 1. So if you see, subtract 11 minus 12. So if you see, you'll see none of the values of y is amongst the acceptable range of 0 to 9. Y is 0 to 9. Okay. Chalo, this needlessly spent some time here, wasted some time. We could have managed a better question in this time frame. And when this number is divided by 36, good question. the remainder is 6. So it's not completely divisible, there's a leftover 6. Now people throw up their hands. I don't know what is supposed to be done here. We learned divisibility rules, but now how do I handle with this? Find the value of x. X is a single digit whole number. Many different ways you can handle it, students. And you can't split this or at least not till the time the remainder is present. Only when you know that a number is divisible by 24, you can say it's divisible by 3 and 8. But if there's a remainder when divided by 24, you can't say the remainder is same when divided by 8 or 3. So no such things, right? So this is a decently challenging question in that case, right? So now here you would need a basic idea of what remainders are. You know the process. Remainders are when you divide what is left over. So if I remove off this 6, so if I remove off 6 from this number, okay, then what will be left over is going to be completely divisible, is divisible by 36. And this kind of a logic or so on gets used quite often in LCM and so on, right? So, you know, they're not compartmentalized learning. You need to have an idea of what the division process is. So you remove that 6, whatever is left is completely divisible. There's no leftovers now, there's no 6 to it. So how do you subtract the 6, especially when there are? And now there are people who get very creative. And I'm just thinking aloud. So when you subtract the 6, you carry a year 1, so that, you know, so there are people who are going to try this question by changing this x as 791, 791, 532, and in place of x now, the digit is x minus 1. And then there's a 10, 10 minus 6 is a 4. So remember, this is just a single digit. Can I do this type of work? Yes, you can. It's a little tricky business now. But when you do, this is divisible by 36. Oh, 36 is 4 and 9. So this is divisible by 36. So this is divisible by 4 as well as 9. They are co-prime. They don't have a common factor. So you can try now. And what is it asking? Find the value of x. So x values are given over here. So another way could be, you know, you get missed out. You just use these values over there and actually divide and check. So which value of this when I put will make it divisible by 36? So I'm not going to now work. I'm just going to plug values. So if I take x as 2, so x minus will become 1. 14. Is 14 divisible? No. If x is 3, 3 minus 1, 24. Is it divisible by 4? Yes. But is it divisible by 9? I have to check later. So let's add the whole din check up. And again, divisibility by 9. Now you can keep dropping 9s. Okay, so I'll do that, dropping 9s. So 9 I drop, 7 and 2 is a 9 I drop, 4 and 5 is a 9 I drop, 6 and 3 is a 9 I drop it. So what is, if you don't like this dropping business, add it yourself. Add the digits on your own, right? So what are the digits that are left? 0. Doesn't adding summation. Now I'm adding the digits. 1 and 4 is a 5. So this is a 5 plus x minus 1. And when you do the x minus 1, again you could say this is a 4 plus x. So remember, what was x? 3. Now if we take 3 and 4, it is not divisible by 9. So this is not my answer. If you take 4, this becomes 34. 34 is not divisible by 4. This is also not my answer. Has to be this. If you take 5, this is 44. Is 44 divisible by 4? Yes. And if you take 5 plus 4, 9. Is it divisible by 9 also? Yes. So this has to be my answer. So this is one particular way where I use the option. Let's quickly wind up the last question. It's gone a little lengthy, this video. So the 10th question. A 5-digit number is made up of the digits 3, 4, 5, 6, 7. each digit appearing exactly once in the number. So basically you rearrange these digits in any possible way. Okay, now this number is divisible by both 11 and 16. Find the digit in the 10,000s position, the leftmost position. So now this is the place where rule of 16 comes in, and if you have only studied the rules for 2, 4, 8, you might not know, but if you have studied it for any power of 2, you know it is the last 4 digits. But then last 4 digits could be a lot of possibilities. Another thought that comes to my mind is, if it's divisible by 16, it is divisible by 2. So this has to be an even number. And if it is an even number, there are only 2 possibilities, 4 or a 6. Then it should also be divisible by 4. So I can try to put in the tens position also. Then it should also be divisible by 8. I can try to put in the hundreds position also. But then, you know, there are branching outs that happen, 4 or a 6. Similarly, there could be further branching outs. So I do not know. And the moment I reach 16, it becomes a little lengthy division. Yeah, it's not very easy. Whereas for 11, can I use something? Yes, for 11, how do we handle? The rule is, you take the alternate digits, the sum of these digits, you call it U. The sum of these 2 digits, you call it T. Okay, now how do I split this such that U minus T is divisible by 11? U minus T could be minus 11, 11, 0, anything, right? So now for a beginner that might mean there are too many ways, I don't know how it is, but for a decently practiced person, this boils down to finding 2 numbers, U and T. I'm not checking which number comes in which position. I'm only checking what can U and T be. And do I know that the sum of U plus T will be the sum of all the digits? Which is 7 and 3, 10, 6 and 4, 10. So the sum has to be 25. And I know U minus T has to be divisible by 11. So the U minus T, now if I make it a 0, that simply means U is equal to T. So split this 25 into 2 parts, 12 and a half, 12 and a half. Now I can't have a 12 and a half, no? So this is not going to work. Could I use a 11 and a minus 11? Yes. So if I use 11, assuming, you know, U is made up of 3 digits, T is made up of 2 digits, maybe U might be bigger, I don't know, but just check it up. Have we done this sum and difference in today's lecture only earlier also? So the way to solve this should be very fast. The sum of this 36 by 2, U is 18, and so T will be 7. Now think, can you find 2 numbers whose sum is going to be 7? Yes, which 2 numbers? And thankfully for me, and look how quickly I moved to the lower sum. Because that's going to be easy, and the only way 2 numbers can add up to 7 is going to be when they are 3 and 4. And the others will automatically add up to 18. I don't have to do anything. I've already put the conditions in place, the correct conditions in place. Oh, so 3 and 4 will come over here and here. The 5, 6, 7 are going to be amongst the U group, alternate digits. And now I can use these also. So now it's almost done, students. 1, 2, 3, 4, 5. Now I know it has to be divisible by 2. So it should be even. But this 3, 4 will come only over here. So I'll not put. So this has to be a 6. And if this is a 6, now this can be a 3 or a 4. Now remember, it should be divisible by 4. So a 46 is not making it divisible by 4. So this has to be a 36. If this is a 36, this has to be a 4. Now I want this number to be divisible by 8 also. Right? So now 7 and 5 are left. Where will which go? Either 5, 7 or 7, 5. You can even write it and divide and check it up, students. Yeah. or else this number should be divisible also by 8. So for 8, is this divisible by 8 as of now? No. So 0 will not be acceptable. If a 0 is not acceptable, let's check if 1 comes in. 1 would make it 8 ones are 8 and 56, 8 sevens are, yes. So 1, 3, 5, 7, anything can come in here to make it divisible by 8. But if anything can come, 5 can also come, 7 can also come, then we are still back to the same question. Where does 5, where does 7 go? So 8 does not really help us. Now whether you put 5 here or 7 here, the divisibility by 11 is guaranteed. Alternate sum is 25, oh sorry, 18, and this is 7. So you will have to use 16. So this number here with a 5 or a 7, when will it be make it divisible by 16? So put a 5 and a check. 16, so I am dividing by 16. For 16 we don't need the leading digit, only this needs to be checked, right? 16 2s are 32. And that is why you should be comfortable with your division, with your multiplication and all also. Now students are going to, how can I make it easy? Why? Divide by 16 is not a very tough one, students. 16 2s are 32. 16 9s are 144. 16 9s are 140. 16 into 8. That's a 128. Now you should know this. 16 into 8 are powers of 2. 2 raised to 4, 2 raised to 3, 2 raised to 7 is 128, and that leaves a 56. So is this divisible by 16? No. So a 5 will not come here. If a 5 will not come here, 5 has to come here, and this will be the number. Now this has to be divisible by 16. You want to check it? Check it. 1648 is divisible. So 16 2s are 32, 153. 16 9s are 144. So that's a 96. 16 6s are 96. It is divisible. So this is the number. So the leading position is 5. So a good tough question from an exam point of view, but pretty doable for one who is well practiced. So if you want to practice such questions, you like the course, the link to the course is in the description. We have different pricing plan. One is a dirt cheap pricing plan of only the study material, and one is with the doubts that you can ask. So make your choice.